Okay, so today we'll start with acids and bases, the introduction of it, and we'll be a bit all over the place, but I will try to keep it as short as possible and as most introduced or most knowledgeable for you. Will be kind of a review for you. Okay, so when we are talking about acid versus bases, what do we know from the previous classes is that acid starts with an H, like hydrochloric acid, fluoric acid, or even organic acid is HC2H3O2. Okay, so they all have in common that they have hydrogen plus. And when we take a look at bases, they all have the hydroxide. So sodium hydroxide, potassium hydroxide, barium hydroxide, they are all bases. However, when a metal is bonded with hydrogen, then what is happening on this case is the sodium is +1 and hydrogen is -1. So when hydrogen is -1, then it's considered to be a base. But in general, we can say that bases have the hydroxide ion. Okay, it was, you know, from chemistry 20 that Arrhenius theory for defining acids and bases is that if it is an acid, then it is releases H plus ion in solution. And if it is a base, Arrhenius said that it releases, and this is from chemistry 20, OH minus ion in solution. Okay, but we know that this is not always true because we have seen and we have seen cases where no hydroxide was present and still it was acting as a base. Okay, now another thing that you have seen and studied on previous chemistry classes is the calculation of pH and pOH. So pH and pOH are a way to give meaning to us, a scale used to give a meaning to us in terms of who is acid and which one is acid and which one is a base, and most likely to compare the acids and bases in between each other. It is a scale that you have seen. It is 7, it goes, you said 0 to 14, and where 7 is neutral and 14, so whatever is between 7 and 14, by the way, it goes beyond 14 and beyond 0. Whatever is between 7 and 14, it's considered to be a base, and whatever is 7 to 0, it's considered to be an acid. But if it is less than 0, negative, then means that it's too much acid. Okay, so now the pH and pOH are calculated as pH is the negative log of the hydronium ion and POH is a negative log of hydroxide ion, concentration of them. Okay, since the concentration is like very small, or it's not our mind cannot perceive it, then we use the pH. This is the only reason. And from here we can say that if we know the pH and we are looking to find the concentration of hydronium, then we will go with 10 to the power of negative pH. And if we know the POH, then we will find the concentration of hydroxide as 10 to the power of negative POH. At 25 degrees and some other conditions, the pH and POH is equal to 14. So in order to bring all those together, what do we have? We have constructed that flowchart or magic box. So if we know the concentration of hydronium and we are looking for the pH, then what we can do is we can go negative log concentration of hydronium. And if we know the pH and we want to calculate POH, then we use the fact that pH plus POH, oops, sorry, pH plus POH is equal to 14. And when we know the value of POH and we want to calculate the concentration of hydroxide, then we calculate it using 10 to the power of negative POH. And now to go in the other direction, if we know the concentration of hydroxide and we want to calculate POH, then we go negative log of hydroxide. If we know the concentration, POH, and we want to calculate pH, then we use the fact that pH plus POH is equal to 14. And if we know the, what color? Okay, and if we know the pH and we want to calculate the concentration of POH, then we use 10 to the power of negative pH. Now, this is what you have done, and probably a flow chart like this or some kind of flow chart like this was given to you when you were on Chemistry 20. However, now we have and probably the teacher was telling you that the connection between the concentration of hydroxide and hydronium will be introduced to you on Chem 30. Now, what it is between the connection between the concentration of hydronium and concentration of hydroxide is that the product of the two is equal to 1.0 times 10 to the power of negative 14, which is known as Kw that is the constant of water is known, because what is happening with water is that it's that is known as the auto-ionization of water. Since we are here, let's talk about this auto-ionization of water and then deal with this this formula here. Okay, that is not quite introduced into chemistry 20. Okay, so now water is a unique solvent. One of its special property is its ability to act either as an acid or as a base. So water is an acid and it is a base. You have seen properties of water in Science 10, in Chemistry 20. Now we will see it from a different perspective. Water function as a base in a reaction with acid. So when we have, let's say, hydrochloric acid, HCl plus H2O, and it is acting as an acid, as a base. Why? Because based on it is accepting one electron. It's forming that, we will say now, it's forming that hydronium ion and Cl minus. They are in aqueous solution. Okay. And it is acting, acting as an acid when it is reacting with a base. So this is reacting, water reacting with an acid, and this one here will be reacting with a base. So what do we see when water is reacting with a base? Let's say with NH3 plus H2O will give us NH4 plus OH minus. They are aqueous solution. So water is a very weak electrolyte. Okay, it's a very weak electrolyte, therefore a poor conductor of electricity, but still it goes into ionization to some extent. So what is happening is water liquid, it's going into ionization of H plus and OH minus. Okay, this very often, this is known as the auto-ionization of water. Okay. Okay. So if we write the equilibrium constant for this reaction, by following the same rules that we set in the previous part of this unit, where we exclude the solids and liquids unless liquid is everything, then we will say that the equilibrium constant for this is the concentration of hydrogen and the concentration of hydroxide minus. Yeah, I do that. The concentration of this is known as, it's a constant value, okay, and it is known with Kw. and it is 1.0 times 10 to the power of negative 14, no units. So Kw is called ion product constant, which is and this is at the 25 degrees Celsius, the concentration of hydrogen plus and the hydroxide ion are equal to each other. Okay, so they are 1.0 times 10 to the power of negative 7 times 1.0 times 10 to the power of negative 7. So therefore, Kw, which is a constant, and we will assume that it is at 25 degrees, will be 1.0 times 10 to the power of negative 14. So this is a constant. Okay, this is where this connection between the hydroxide and hydronium ion concentration comes from. Okay, so if we know the concentration of hydroxide, then we can find the concentration of hydronium ion using Kw value. So let's stay a bit here on this, give an example. So let's suppose that the concentration of hydroxide ion at a certain household ammonium cleaning solution is 0.0025 moles per liter. What is the concentration of hydrogen? When you see either the hydrogen or concentration of hydrogen or concentration of hydronium is the same thing. They are equal to each other. Okay, so now using the fact that Kw is equal to concentration of hydroxide times concentration of hydronium, then we can find that the concentration of hydronium, which is the same as saying concentration of hydrogen, is Kw over the concentration of hydroxide, or 1.0 times 10 to the power of negative 14 over, in this case, 0.0025. So when you enter this in your calculator, the concentration of hydronium, which is the same as the concentration of hydrogen, will be 4.0 times 10 to the power of negative 12 moles per liter. Okay. This is how we use that auto-ionization of water. Now let's do some examples into calculating the pH or pOH. So let's suppose that we have the concentration of H plus or hydronium. They are the same thing. Is in a bottle is 3.2 times 10 to the power of negative 4 moles per liter. And then let's calculate the pH and pOH. So the pH will be negative log of the concentration of hydronium, or negative log of the concentration of hydrogen, which are exactly the same thing. So negative log 3.2 times 10 to the power of negative 4. So pH will be 3.49. Keep in mind when we are talking about pH, the sig digs, even though that it looks like there are three, the sig digs actually are counted only the digits after the decimal point, because the 3, it's more the exponent. And now if we want to calculate the POH, then POH will be 14 minus pH, or 14 minus 3.49. So POH will be 10.51. So this will be pH, and it is two significant digits. And as I said, for pH and POH, the significant digits are counted only the decimals after the decimal point. Let's see a case in which we are calculating the when we know the concentration of hydroxide. So in a solution of sodium, let's say sodium hydroxide, the concentration of hydroxide is 2.9 times 10 to the power of negative 4 moles per liters. And let's calculate pH and POH. So since we know the concentration of OH, or hydroxide, then we'll start with POH as negative log concentration of hydroxide. So will be negative log 2.9 times 10 to the power of negative 4. Then POH will be equals to 3.54. And in order to calculate pH, then we go 14 minus 3.54, 14 minus 3.54 is 10.46. So the POH will be this one, and pH will be 10.46. Again, as I said, keep in mind that pH and POH, they have the significant digits are counted only the digits after the decimal point, because this is the whole number is the exponent, and when we express it into the power of, then 10 to the power of, then that is not counted as the. If you want to try, and I challenge you to try, using the fact that KW is 1.0 times 10 to the power of negative 14, you can calculate the concentration of hydroxide using this, knowing that the concentration of hydronium, the concentration of hydroxide is 2.9 times 10 to the power of negative 4, and then find the pH and POH. You should have pretty much the same values. Okay, so this is for the introduction to acids and bases. I will see other videos in which we are explaining the table, acids and bases table in your data booklet.